Hello, this is Jeff Bowen. Welcome back to another video on geometry problems. Here, we're working with distances, midpoints, and we're trying to identify congruent segments in a plane. Here we're given three different coordinate points. Well, actually we have 6 coordinate points, and we're trying to identify whether or not some of these segments are congruent or not. The segments that we're given are PQ, RS, and TV. Right? And visually, if we wanted to look at this, let's take a step back. Let's just look at this top one, P, the segment PQ, the joint between the spot P and spot Q. Well, I'm just going to throw this on here real quick. All right. PQ. The first point there is -2, 2. And the second point is 3, 4. 1, 2, 3. 2, 3, 4. All right. We have a segment here. This is point P. This is point Q. And the segment is PQ. All right. And that is the line. All right. And this line has a magnitude. It has a distance between the point P and the point Q. And we can use our distance formula as we previously defined it to find what that value is. And just to review, the distance formula is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1, also squared. All right, so that's our distance formula. We have 2 points here. This is -2, 2, and this is q, which is 3, 4. All right, so let's plug some of these numbers into our formula. All right, x sub 2, we'll let that be 3, minus x sub 1, that's -2, that's squared. Y sub 2, we'll let that be 4. And y sub 1, we'll let that be 2. Squared. We're taking the square root of this whole thing. 3 minus -2, well, that's 5. 5 squared is 25. 4 minus 2 is 2, and 2 squared is 4. And thus, adding these together, we get the square root of 29. Okay? So, for the distance between P and Q, we have the square root of 29. Let's come back over here. PQ is equal to the square root of 29. All right. We now have 4 more points or 2 more segments. Let's go ahead and find out what those are. Staying with the distance formula, I'm going to get rid of these points right now. I mean, technically they're still around, but we have it recorded here. We know what the distance between P and Q is. It's the square root of 29. Let's go ahead and find out what R is. All right. I'm going to plot this one and do the same thing, and then I'm going to skip the plotting for TV, and we're just going to put a little line above that. We're just going to use the formula. So for this one, -6, 2, that's our first point. That is R, and S is -7, 7. It's right around there. All right. We have a right triangle here, or you could say that the right triangle is found by this. It doesn't matter. It doesn't matter. All right. So this here, this was the point -6, 2. And this up here, this was the point -7, 7. We're going to use the distance formula to determine what the distance between R and S is. X sub 2 is -7 minus x sub 1 is negative 6 minus negative 6 squared plus y sub 2, that's 7, minus y sub 1 is 2 squared. We're taking the square root of all that. Negative 6 minus negative 7 minus negative 6. Well, that's negative 7 plus 6. That should just be 1 squared, which is 1. Right? 1 squared is 1. 7 minus 2, that's 5. 5 squared is 25. Add those together. It's 26. All right, so the distance here, the distance between these 2 points is the square root of 26. So RS is equal to square root of 26. All right, let's finish this up. Let's find out what the distance between t and v is using our distance formula. First, x sub 2. Well, x sub 2 is negative 6 minus x sub 1 is negative 5. All right, squared plus y sub 2, negative 2, minus y sub 1, 8, squared, taking the square root of that whole thing, and negative 6 minus negative 5, well, that's negative 6 plus 5, which is negative 1. Negative 1 squared is 1. Negative 2 minus 8, well, that's negative 10. Negative 10 squared is 100. And 1 plus 100 is 101. And so the distance between t and v is equal to the square root of 101. All right. So the last part of this problem asks for the following, and I'll read this off of what I have right here. It gives us these endpoints in these segments. It wants us to determine the length of each segment. We've done that. We have the length of each segment. Now it wants us to check to see whether these following statements are true. So here are the statements they want us to verify. PQ is congruent to RS, right, in these segments. PQ is congruent to TV. And lastly, RS is congruent to TV. They give us a last option, which is none of these are true. All right, so we're supposed to select which ones are true. Well, let's see what we got. PQ is square root of 29. RS is square root of 26. Is the square root of 29 equal to the square root of 26? No, that's not true. Segment RS is equal to the square root of 26. All right, is PQ, segment PQ, equal to, segment PQ is square root of 29 again. Segment TV is square root of 101. Are those two things the same? No, those are two different numbers. They are not the same. Lastly, segment RS, is that congruent to segment TV? Is square root of 26 equal to the square root of 101? No, that is not true. All right, so none of these are true. So the final answer is none of them are true. All right, thank you very much. If you have any questions, let me know. Have a great day. Bye.